So my name's Aaron Markward, and I'm the regional sales manager for the commercial plumbing division of Thermo Megatech, and this is going to be a presentation on this circuit solver. So at the core of all of our products is this thermostatic actuator. So the way this works, it's like a thermostat in your car. It uses a paraffin wax actuator. As you can see in the top left corner here, Steve, maybe you can't, but in the top left corner here, there is an actuator in the cold position where the wax is in its solid state. And what happens when it reaches its melting point, this wax actually pushes against a diaphragm and moves a piston to either close or open an orifice. And we create our own waxes in-house, so we have the ability to create the melting point at anywhere from 30 degrees Fahrenheit to 250 degrees Fahrenheit. Like I said, that's the core of all of our valves. It's this thermostatic wax. So the first question I pose here is, what is the purpose of a recirculation system? As we all know, recirculation systems are used to ensure hot water is available at all of these fixtures. Why do we need to balance these recirculation systems? Because water flows to the path of least resistance. If you were to allow it, water would go to the easiest circuit to go through all day long and ignore those furthest circuits, so hot water would not be available the furthest fixture away for some time. And what challenges are still present? I'll go through that in the later portions of this presentation as well. So here are the different types of balancing valves. There's manual balancing valve circuit setters, which you're familiar with. Automatic, which would be a fixed flow, is how we describe them in-house at least. So what you do with these automatic, which I believe is what you were describing from Victaulic, they have a fixed flow cartridge that works at a specified GPM at all times, regardless of the pressure. So it's pressure independent. So our thermostatic valve, which is a circuit solver, which is a thermostatic balancing valve, self-actuating temperature-based circuit solver. The position of the piston is dependent on what the water temperature is, and that's going to give you at temperature water instantaneously, which I'll go through more in depth here. So these are just pictures of circuit setters that you're familiar with, I'm sure. And these are automatic balancing valves, those fixed flow valves that give you a specified GPM, let's say a half GPM or 1 GPM. So with manual balancing, as you know, you have to calculate and specify a GPM for each balancing valve, and then you have to do that. You have to get a commissioning tool, find the pressure drop across the valve to know exactly what GPM is going through that branch, and it's an incredibly iterative task. And it's done in a inherently static condition. So when the building is not occupied, it's done then, and then it's occupied. The pressure changes throughout the building as soon as it's occupied. So there's a lot of challenges that come with that. The ambient temperature is going to change the water temperature as well. And as I mentioned before, the building occupancy. If certain floors are utilized more often than other floors, the pressure is all out of whack, so the building is not technically balanced anymore. As I mentioned, it's an iterative task, so you have to keep going back and forth to different valves, and you have to have at least two people, a certified plumber, going back and forth to tweak these valves back and forth, and they're pressure dependent. So like I said before, occupancy is going to be a big factor in balancing the system. And there's also oftentimes a conflict between the engineer and contractors. So if a building's not balanced, the engineer will say the contractor didn't balance it correctly. And then the contractor will come back and say, hey, you didn't give us the correct parameters to balance it to. The design's off, something like that. So what we've done is we think that this product has created one less difficulty working with engineer and contractors, so it unifies them in a sense. So this is an automatic balancing valve, that fixed flow device that I was talking about before. They have replaceable internals that allow you to have specified GPM, let's say a half GPM. That's pretty typical for a branch. These valves are prone to clogging because of their small clearances, and they are still dependent on calculations. A lot of times we do see guesstimations, and that can oversize your recirc pump. So what we say with circuit solvers, you can true size your recirc pump. Once again, getting that a little bit later. What these things do, they control the GPM in a branch rather than controlling the temperature. So balancing is all about what we want with balancing is temperature at each fixture. So we want a temperature device to do that. That's where the circuit solver comes into play. So this is actually a video of the circuit solver modulating back and forth. What we did here was we took a hairdryer and just blew it on there for a couple minutes and watched it modulate back and forth so we could get this video. It just shows that there is a considerable amount of work going in there. So it automatically and continuously adjusts itself to maintain the specified water temperature. So that's going to increase the flow of water that cools below your specified set point to the return, and it's going to reduce water that's at temperature going to the return. So it's a temperature device solving a temperature problem. It's pretty, I'm going to beat that to death probably. It's a temperature device for a temperature problem because that's our tagline there. So this would be installed in the same location that you install your manual balancing valve or fixed flow valves downstream of the last fixture of the supply on the return. Sometimes we do see balancing valves in strange places, so I always like to specify downstream of that last fixture, just to be clear. So it's dynamic, it's self-actuating. It doesn't require a calculated flow on a branch level. It adjusts the system demands as parameters change. So what it's going to do, it's going to open up when water is not at temperature, creating a higher GPM. And then as soon as it reaches temperature, it's going to close off. So it's going to be satisfied, and it's going to create a steady state point at a point. And that's going to be the typical GPM needed in that branch. It eliminates the need for iterative setting, that labor, so you just install it and you forget it. It's very, very simple, and it installs the way the engineer designed it. So if they want 120-degree water, you install a 120-degree circuit solver at the end of that branch, and that'll maintain 120 degrees. As I mentioned before, we do have wax ranging from anywhere from 30 degrees Fahrenheit to 250, so we can cover anything you need in domestic hot water. Clearly not going to need either of those extremes, but we do have it. So you just need to match the pipe size at the end of the supply, and that's going to be your circuit solver size, and select the closing temperature, which will be the temperature that the circuit solver maintains. So our most frequently specified temperatures are 120, 110, and 115 in that order. We are seeing it creep up a bit due to Legionella concerns, so high temperature maintenance for recirculation is one way that people are mitigating this Legionella. So we see 130 used quite frequently in Canada. I think they're standardizing on 130 and 135. In the US, on the West Coast, we're seeing it go up pretty quickly too, to that 125 to 135 range. It's ideal for a retrofit because it automatically balances your existing hot water system, so you don't have to have a headache going back and rebalancing every branch, because if you have a retrofit, you're gonna have to go back to all those branches and iteratively set them once again. So this is great. This is great because you just install it and the system automatically balances itself.
For temperature, not flow, right?
What's that?
For temperature, not flow.
Yes, it's going to maintain temperature, not a specific flow. So that paraffin wax will see what temperature the water is by its melting point, essentially. And when it sees that it's at temperature, it will close off. It doesn't close off all the way because we don't want to deadhead any recirc pumps or anything. So there's always bypass flow. But then when it sees that the water's cooling down, it modulates open more, so to the more open position, and creates a greater flow, which then creates a higher temperature rate. So the greater the flow, the higher the temperature.
Yeah, how much bypass flow would you have on a, say, a half GPM circuit solver?
0.3 GPM-ish.
You're reducing it less than half when it's fully closed.
So it goes by, so it's not a half GPM circuit solver, it's a 120 circuit solver. So it can go from, it can allow up to 1.5 GPMs through it, or as low as 0.3 GPM. So what it does is it then creates a steady state point, as I mentioned before, and pretty much sits at that steady state point, allowing around either 0.5 GPM, if that is the actual flow to offset heat loss. It allows that through it most of the time, and then when a fixture is used, it'll close off more because it's going to draw that hot water, and it'll close off to its 0.3 GPM because it doesn't need that flow rate at that point.
Okay.
So, as I mentioned, always allow some flow, never fully closed. Even low flow helps thwart bacteria growth. It can still run a sanitizing flush through the system. We do have a specific valve for that high temperature flush. If you guys ever deal with that, that's a specific valve we have that has a bypass flow to it, which I can go over more later when I go over the variations that we have. Like I said, I'm going to beat this to death. It's a temperature device solving a temperature problem. So it's not a flow device trying to solve this problem. It will see the temperature that is in the water, and it will modulate accordingly to create the temperature to offset heat loss. Again, you just choose your line size, and we have sizes available from 1/2 inch all the way up to 2 inches. Our most popular are clearly going to be 1/2 inch and 3/4. 1 inch is a little bit more popular in recent years than it has been. 2 inches is still fairly infrequent. You would need a lot of flow for a 2 inch. And then, as I said before, most frequently specified temperatures are 110, 115, and 120. So the way these are ordered by model number is CS. Then what you would do is just the line size, so 3/4 inch, 3/4 inch line, and if you want 120 degrees at the end, 120. So pump sizing. This is a question we get sometimes. They say you have to size your pump differently if you use these, which is not the case. We say anything you're doing now, you can continue to do, but what we do suggest is using ASPE guidelines for calculating the flow to offset heat loss for your pump sizing, because that's going to give you a true size pump. And a lot of times, individuals are worried that they're going to not have enough flow, so they oversize their pump just to compensate for those fixed flow devices and those manual balancing valves. So they oversize it for any issues that could occur, and they want to just make sure they have more than enough flow. But with the circuit solver, you can truly size your pump. You can accurately size it without the worry that you're not going to get enough flow. So we do see about 90% of our installations are with constant speed pumps because they're just the most popular right now. We are seeing a little bit of a trend the other way now with variable speed pumps. Variable speed pumps and circuit solver work extremely well together due to the fact that they also are dynamic. So if you set them to constant pressure mode, what's going to happen is they're going to see when the circuit solver closes off, meaning they're satisfied at temperature, and they will slow down. So basically, the circuit solvers are taking care of the temperature throughout the building, while the pump is going to take care of the pressure. So it's a great marriage. It really is. Like I said before, about 90% of our installations are with constant speed, so they certainly work too. Just it is a very efficient marriage with the VFD pumps. How's the water in Washington? Is it kind of hard? Is it normal?
It eats away pipe pretty good in Seattle.
Okay. Yeah, so
Copper doesn't last very long. It destroyed Aquatherm.
oh wow.
It's
So
not good.
so in Warminster, Pennsylvania,
Highly chemically treated.
okay. Yeah, so our valve is made out of stainless steel. and it's very heavy duty. All the internals are stainless steel as well, so it's pretty impervious to chemical treatments and stuff like that. And we have I think the water hardness in Warminster, Pennsylvania, where we're based, is about 228 parts per million of dissolved solids in our water, which 180 is considered very hard. So we have extremely hard water in Warminster. And we have a couple valves testing there at all times. I've had a couple for about 8 years. And we take it out every year for marking literature just to show that it hasn't scaled or anything. If you're only on the phone, you're not going to see this next picture, but this is an image of one of our valves taken out after 6 years. I need to update this slide actually because we have it for 8 years now, but it looks extremely similar to this one. It's got nothing growing on it or anything like that. It's not clogged, and that's because it is constantly modulating back and forth, so it is cleaning itself, and it is stainless steel, so it's pretty impervious to that stuff. So if that's where you have this valve's great for those hard water and chemically treated water systems. So as I mentioned, it's 100% stainless steel, NSF 61 certified. It's lead-free. We have Massachusetts board approval. And something I always do like to point out is that this NSF 61 certification is required in, I believe, definitely in Washington. But this is an outdated number now, too. It says 45 states. I think it's 48 states now. And a lot of manufacturers have balancing valves that are NSF 61 compliant, but not certified, which is not technically enough. So they may have 372 certification, but they use the word compliant to kind of get around that, which they're not allowed in potable water systems technically. So now I'll just go through our different variations of circuit solvers. So this is our circuit solver union. This has an integrated union and check valve in it. So it's got it's got an O-ring in it, so you can have a hand-tight leak-free seal, and we have this from 1/2 inch all the way up to 1 inch. It does have an optional check valve, which seems to be an optional integrated check valve, which seems to be the most popular valve we sell now, just because if you are close enough to a fixture and you if the circuit solver is close enough to a fixture, I should say, and you turn it on, the pressure difference can sometimes cause backflow. So that check valve just prevents that. It's very convenient. And this is going to be the core of the rest of our assemblies. So we have a complete assembly as well, where it's just our circuit solver union with ball valves on either side, fully leak tested in the factory, and it arrives with ball valves on either side. So it just minimizes your leak points in the field. We have this in sizes up to 1 inch again. We have strainers available too. If you have a lot of particulates in your water and they've been a problem for valves before, we do provide a strainer. Once again, that's optional. And we do have Pro Press ends fully leak tested once again. And something more recent that we came out with was our thermometer, just so you can see. It's a pretty much a commissioning type tool here. The thermometer on the return end of the circuit solver, which will give you a temperature reading, so you know that you are getting temperature. So as I mentioned before, we have a valve dedicated for sanitary flushes. What this does is it balances your system at your low temperature, let's say 120 degrees, and it has a bypass in it as well that allows you to do a sanitary flush at 170 degrees, 160, 180, whatever it may be, for whatever time period you need. So what this does, I have a rendering here that I'm going to play for you really quickly. So what happens is this first actuator will balance the system at about 120 degrees if this is a 120 valve. So that'll modulate back and forth. And then when it sees about 20 degrees over that, it'll automatically go into bypass mode and go through that orifice there and allow bypass flow to go to the secondary actuator. When this actuator sees about 160, 170 degrees, I paused it. It will start to modulate, and this is going to balance your system at 160 or 170 degrees to ensure that all the nooks and crannies in your in your system are going to get that high temperature to kill all the Legionella and bacteria in your system. So the big points to remember: it's NSF 61 certified. It automatically balances your recirculation system based on temperature and not flow. So these valves help meet the design criteria, and they ensure that you have temperature at your fixtures at all times, especially in no use periods. Ensures hot water is rapidly delivered, promotes water conservation, supports efforts towards LEED certification. And here's that last time I'll beating it to death. It is a temperature control device solving a temperature problem.